people wouldn't waste any part of a slaughtered animal, not even its blood. Black pudding also contains several dry ingredients: barley, allspice, dried onions, spices and other seasonings, and wheat flour. The pig's blood is also in dried form. They begin by filling cotton bags with barley and submerging them in boiling water overnight. The bags are porous, so the barley absorbs the water, swelling and softening as it cooks. Once the barley is ready, they drain the water out of the cook tank. Then cut open the bags and empty the cooked barley into a tub. The barley and other dry ingredients will make up about a third of the pudding mix. Another third is the pig's blood, and the last third meat fat. They boil pork fat in a cook tank for 2 hours. Then they strain out the water and transfer the fat to a tub. In another cook tank, they boil smoked bacon fat for 2 hours. Then they scoop out and strain that fat and drop it into a bin as well. The scraps of meat clinging to the pieces of fat will give the black pudding extra flavor. Next, workers empty the 2 bins of fat into a mincer. Then they take dried onions and hydrate them with stock from the smoked bacon cook tank. This produces gravy. They pour this gravy, along with the cooked barley, into the mincer. Next, they add the flour and mince some more. And then the dried pig's blood. Besides turning the ingredients a rich color, the blood makes black pudding a rich source of iron and protein. They mince the ingredients until the mixture is smooth. Then they transfer it to the stuffing line. A worker pumps a specific quantity into a nylon casing, then staples each end of the casing closed. This is the 340-gram retail size. The factory also packages larger formats for restaurants, delicatessens, and caterers. From the stuffing line, the black puddings go into a steam cooker. Once their internal temperature reaches 85 degrees Celsius, which takes about 2 hours, they come out of the oven, their texture now like a dense chocolate pudding. After cooling overnight, each black pudding goes into a printed plastic bag. A vacuum machine sucks out all the air and heat seals the package. This improves the product's shelf life. From there, the puddings drop into a tank of hot water. This shrinks the plastic package tightly around the casing. Even within the same country, black pudding recipes vary by region. This smooth textured pudding is typical of eastern Scotland. In western Scotland, they use oatmeal instead of barley, and in the north of England, they use big, usually visible chunks of fat, both producing a black pudding that's coarser in texture but equally delicious. The earliest automobiles used a tiller for steering. That's a lever attached to a rudder. The first steering wheel appeared in 1894 in a car built by the Panhard Company of France. Today, the steering wheel is a multitasking component, integrating control switches and the driver's side airbag. A car steering wheel looks simple enough, a stylish ring with a horn in the middle and switches to operate the cruise control and other functions. Yet, despite this simplicity, a steering wheel design undergoes years of development and testing for safety, durability, appearance, and function. The manufacturing process begins with the armature, the internal support structure. It's made of either aluminum or magnesium, strong yet lightweight metals. The factory's die casting system injects the hot molten metal into an armature-shaped mold. Once the metal solidifies, the machine ejects the casting from the mold. The metal is still hot, so a robot arm moves the cast armature to a cooling area where cold air blows on it. They remove the excess metal left over from the casting process in one strike with a trimming die. And with that, the armature is finished and the steering wheel assembly can begin. First, a robot installs 4 rivets, the contact points for the horn system. When you press to honk the horn, the rivets complete an electrical circuit enabling the horn to sound. Next, a computer-guided engraver marks a lot number for quality control tracking. This demonstration shows the basis of the next step. When mixed together, these 2 polyurethane chemicals react to each other and produce an expanding foam. By guiding this expansion within the confines of a mold, one can make this dense foam assume a specific shape, such as that of a steering wheel. The process is called reaction injection molding. They coat the mold cavity with a release agent to prevent sticking. Place the armature inside, then inject the polyurethane chemicals. The chemicals react, and the foam instantly expands within the mold cavity, encasing the armature. Prior to injection, they also spray the mold cavity with protective paint. It tints the foam the required color, in this case black. It also protects the foam against wear and UV damage. The injection molding process leaves excess polyurethane on the steering wheel, so the next step is to trim it off. With the steering wheel structure complete, it's now time to install the components. These switches control the features operable from the steering wheel. Workers assemble them into housings called finishers. The finishers are molded out of plastic resin, then coated with metallic paint for a high-end look. The switch wiring has already been assembled into a unit called a wire harness. They connect the harness to the switches and install it onto the steering wheel. Then they check that everything functions properly. And if it does, they mark the assembly to show that it passes this stage of quality control. After applying a barcode sticker, they route the wiring through the steering wheel to prepare it for final assembly on the automaker's assembly line. Next, they install spring mechanisms. These support the airbag module, enabling it to move in and out when you sound the horn. Then they attach the horn plate, to which the car maker will later attach the driver's side airbag module. They take the ground wire in the wire harness and position it, then flip the steering wheel and secure the switch finishers to the exposed back of the armature. Then they install a back cover made of plastic resin, the color matching the rest of the steering wheel. A robot arm equipped with a camera performs a thorough quality control inspection. While the basics are the same, features vary from model to model. Higher-end steering wheels are wrapped in leather and often have extra switch controls for the audio system and for hands-free use of a cell phone. People have always used color as a means of expression. Prehistoric man created paint from a mix of dirt and animal fat or spit. Over the centuries, pigment production has become a lot more sophisticated. Chemical manufacturing produces synthetic mineral pigments to add color to the products in our world. From pavers to paint to plastic and cosmetics, this is where the color comes from, synthetic mineral pigments. They start with a salt recycled from the steel industry. In this case, it's iron sulfate, which has a bluish-green hue. They add warm water and they're ready for the next ingredient. High-quality scrap. It's another source of iron and it's about to be recycled into pigment. Crane claws transfer it to the mix. Chemicals are added. Every so often, a technician scrutinizes a sample of the yellow slurry. If he decides the color or thickness aren't quite right, adjustments will be made. The slurry now flows over a perforated metal drum with a filter cloth stretched across it as a spray of water rinses off the salt. The fluid in the yellow slurry is sucked through the filter cloth and into the drum, leaving a more concentrated pigment on the surface called filter cake. The filter cake falls in chunks onto a screw conveyor and ends up at the top of a towering spray dryer. Inside, machinery presses the highly concentrated pigment through the holes of a rotating disc. This causes a spray of droplets that, when exposed to hot air, dries into pigment particles. This yellow pigment is now ready to be mixed into an emulsion paint for coloring wallpaper. A generous amount can produce a bolder shade. A little less, and it's a more mellow yellow. To make black pigment, they start with cast iron filings, another form of automotive scrap. This magnetic crane transfers the filings for production. And again, it will take a chemical reaction to produce the pigment slurry. The chemical reaction also generates energy that's recovered and used in the manufacturing process. They wash and thicken the black slurry on a revolving drum, just like they did for the yellow pigment. But this thick paste won't just be used to make black pigment, it will also be used to make red. For the dramatic conversion to red, the paste flows directly into a kiln, where it's baked until dry. They introduce air and increase the temperature to 850 degrees Celsius, making the black particle turn red. They transfer the red pigment to a drum, where they mix the pigment and adjust the color properties. Then they grind it to a finer consistency. Once the pigment is packaged in paper bags, it's ready for transport or warehousing. Like sugar, pigment comes in both a powdered and granulated form. This demonstration shows the difference between the two. The powdered pigment is more clumpy and doesn't flow from the opened end of the beaker. By contrast, the granular pigments are tiny microbeads that flow freely, which makes it desirable for users who want to mix and meter pigments more easily. To test how the pigment would color brick, they mix red pigment with a concrete substitute and compare the result to the standard to confirm that they match up. But sometimes they need a real concrete example of a pigment's color tone, so they add a small amount to a mixer full of aggregate, water, and cement. The mixer rotates, and once the ingredients are thoroughly blended, they open the lid to reveal the red brick paste. They scoop it up for transfer to a brick-forming machine, and then fill brick forms with the paste. They activate a plunger that tamps it down to compact it into the forms, producing bricks. Red, black, or yellow, these pigments are sure to make things more colorful.